Hello everyone and welcome to this module on PN junction diode and its applications. In this video we are going to see the action of PN junction diode under the forward bias conditions. So we will discuss the connections in forward bias again, the circuit diagram of a PN junction diode in forward bias and effect of externally applied voltage on internal potential barrier and the consequent current that flows. This is the diagram which depicts the forward biased PN junction. So, reminding again, when positive terminal of the external voltage source is connected to the P region, you can see here positive terminal is connected to P region and the negative terminal is connected to the N region of the diode, then the diode is said to be forward biased. Since the junction is depleted of the majority charge carriers and new majority charge carriers cannot arrive there, the resistance of the depletion region is very high compared to the remaining part of the semiconductor where mobile carriers are available in plenty. Therefore, an externally applied bias voltage appears entirely across the depletion layer. It acts opposite to the internal potential barrier V0 and reduces the effective voltage across the junction to V0 minus V. It means that a decrease in the electric field acts across the depletion layer. As the field intensity decreases, the majority charge carriers push into the depletion layer and the width of the depletion layer gets reduced. This means that if the width of the depletion layer reduces, the potential barrier also reduces. The lowering of the potential barrier increases the migration of the majority carriers across the junction. It causes an increase in the diffusion current components since electrons and holes with lower energy or energy lower than EV0 can diffuse across the junction. However, the current due to minority carriers does not change. As a result, a net current flows from P region to N region due to the diffusion of majority charge carriers through the junction. Thus, the action of the forward bias is to disturb the equilibrium and cause a current flow through the diode. The various current components in a forward biased PN junction are shown in this diagram. You can see JHP is the diffusion current density due to the migration of majority holes from P to N region. JEN is the diffusion current density due to the migration of majority electrons from E to N to P region, but you can see the direction of both the currents is same and this causes a net current flow through the junction in forward bias. JEP and JHN are the drift current densities due to electrons from P to N and holes from N to P respectively. They also have the same current directions, but now in the forward bias, since the magnitude of drift currents do not change, but the overall magnitude of diffusion currents is more, therefore, a net current flows through the diode from P to N region.